right, on today's episode of Python Papi, we're back inside our Tensorflow course, and we're still going over our building visual transformers from scratch module. Let's have a look at what we went over today. And yesterday, if you recall, we did get our code to run from the error that we had initially. We fixed everything, get everything smoothed out, and we were able to move forward. So today, we were able to start taking more notes and actually modify another piece of our code that we're going to go over today. And I will keep you posted on that. So let's do some light reading and then touch on that. So now let's take what we have here and modify our patch encoder. We'll be taking the parameters from the embedding from line 713 and added it to the parameters of the embedding of line 520. Let me show you the 513 really quickly. So we have 513 here, as you can see. Well, it's this one here is the 514 one because the 513 one didn't work. The 256 didn't work. Remember, we had to change it back to the 1000 parameter by 730 by 768. So that's when we took over to the 520. Let me show you that really quickly. 520. So you can see here we're in our 520. This is our patch encoder. This is the one we're going to be modifying and add all of the changes to everything that comes up next. So what was the first change here? The five. Okay, it was the embeddings. So we did that one already. Let me see the 1000. So we have here our number of patches and our hidden size. You can see here we have our self.positional embedding equals embedding. We're going to add our number of patches, our hidden size. That's going to represent our 1,768. This is the original version that we were running, the self.position embedding. Embedding is just an embedding method. This time we added the two parameters to our embedding method, which is number of patches and hidden size. So we commented out the original and we put the modified version that we're going to be running. That was the first one we did, the first update to our encoder patch. We also, let me see what else here. We also added this output equals self.linear projection patches plus self.positional embedding. And then for this embedding method, we added the embedding input. And you see we got that embedding input from here. The tf.range, start equals 0, limit equals self dot number of patches, delta equals 1. So what's going on here with our embedding input? We're going to get a range of our inputs starting from 0. The limit is going to be self number of patches. That means we're going to start from 0, and our limit or our max is going to be the number of patches we have, and the delta equals 1. The delta is the number we're going to count by. So let's say we have 0 starting number and we have 100 patches. The delta means we're going to count each patch one by one. Let's say if we had a delta of 3, we would count by 3. So if we had a start of 0 and a limit equals of 100, we would count from 0 to 100 by 3. So it would be 3, 6, 9, 12, 15. That's all the delta determines is how much we count by from our 0 to our ending location. So that's that right there. And we did have something else. I'm trying to see exactly what else do we have. Oh, yeah, the self dot number of patches equals number of patches. We actually had to add this because we wanted to add our number of patches as a parameter to one of our methods. Let me see where exactly we added that so I can show you exactly where we added it for sure. This is it here, the number of patches. So initially we couldn't put number of patches here for the limit because it wasn't initialized. So that's why we came up here and added the self dot number of patches equals number of patches, which means we put the number of patches and stored it in a variable self dot number of patches, and then we actually passed that as the parameter for our limit in our range here. So you can see it. That's why we have the self dot number of patches. So basically, that's what we did. We modified our encoder, and we're actually going to run this overnight to see if it comes up with anything different. So everything's exactly the same. The only thing we did, we modified the dimensions and the specifications of our patch encoder. So like I said, we're going to run this overnight and see what new things we get after we added and took away some things from this encoder and see what we get for shapes and sizes and things of that nature. But of course, I will keep you posted every step of the way, and we will dissect and detail everything that happens overnight from running the program, and I will share that with you tomorrow. But of course, it's the Python Poppy. You guys stay Gucci.